So yesterday we started interpreting graphs. Today we're going to do the same thing. Tomorrow we're going to do the same thing. Make sure you have your computer with you tomorrow. We will do an online activity tomorrow. Okay. Here in bell work, though, we're talking about motion. So it is slightly different. There is motion again in this chapter. The good news is I'm not really adding anything new motion-wise. We're looking at it again, but it's stuff we've already seen. So it's just basically, hey, don't forget about this. We did it before. Don't forget. Okay. We're going to spend Friday doing motion AP questions. But today, let's just look at this bell work. This is a graph of velocity. So always pay attention to what the graph is. It's velocity. When is that velocity graph? When are you moving forward? What has to be true about velocity to be moving forward? Velocity needs to be positive. So show me with your fingers, how many intervals are you going to have here for moving forward? 2. Jonah, what are my 2 intervals going to be? 0 to 1 and 5 to 8, because those are the 2 places where his velocity is positive. Good. So obviously, if I'm moving backwards, what's going to be true about my velocity? Velocity is negative. Okay. So Jesse, when is my velocity going to be negative? 1 to 5. That's it. Good. Questions on moving forward, moving backwards. Velocity positive, velocity negative. That's not too bad. Let's do the next one. Now we're talking about acceleration being positive. The first thing we have to think about is, what are you looking for on this velocity graph if I want to talk about acceleration? The derivative, the slope. What needs to be true about velocity then? What has to be true about this graph? It's got to be increasing or positive slope. I didn't leave myself enough space. Sorry, I'm jamming that on there. But velocity needs to be increasing. Show me with your fingers, how many intervals are you going to have positive acceleration? Just 1. Positive slope, it is going to be from 3 to 6. When is my acceleration negative? Oh, acceleration negative, that means the derivative, velocity, needs to be decreasing. That means the derivative has negative slope. So for that one, 0 to 2 and 6 to 8. Questions with any of that part? And now we get into the next one. We're talking about speeding up and slowing down. We've done this before. And looking at a graph, we can come up with that distinction. Okay? Looking at this graph, show me with your fingers, how many intervals are you speeding up? How many different intervals are you speeding up here? The answer is 2. Jalen, when am I speeding up here? 1 to 2, you are speeding up. And when else are you speeding up? And 5 to 6. Those are the 2 spots. And looking at a graph, I've trained you that when you look at your graph, you'll say, oh, it's because the velocity is getting further away from 0. But that's not how we're going to justify on the AP exam. When we justify on the AP exam, we need to compare what is the velocity and what is the acceleration during that time. So talk with your neighbor. You're looking at these 2 elements. From here, Jalen said we're speeding up, and here we said we are speeding up. What is true about velocity and acceleration during those time intervals? Talk to you. What is true about velocity and acceleration during both those time intervals? Anybody got something for me? Jalen? The signs, velocity and acceleration, have the same signs. That is the justification to speeding up. Okay? Look at that first interval. What is true about the velocity right here? It's negative because I'm below the x-axis. What is true about the acceleration during that time interval? It's negative. If both your signs for velocity and acceleration are the same, you're going to be getting further away from 0. Okay, same thing right here. My velocity is positive because I'm above the x-axis. My acceleration is also positive because I have positive slope. When you have the same signs, velocity and acceleration, you are speeding up. And that is the only justification you need for speeding up. It's the only justification you are going to use. You don't get to use anything else. You have to talk about velocity, you have to talk about acceleration. Okay, so slowing down. I'm slowing down in the other spots, right there, and right there. So from 0 to 1, from 3 to 5 and from 6 to 8. Talk with your neighbor and describe what is the justification. How do I know I'm slowing down during those time intervals? Talk. I am slowing down during those time intervals. What is true about velocity and acceleration? Different signs. They have different signs. If you have different signs, you're going to be getting closer to 0. Okay, like right here, my velocity is positive, but my acceleration is negative because I'm above the x-axis, but I have negative slope. Right here, my velocity is negative, but my acceleration is positive. I'm below the x-axis, but I have positive slope. And again, velocity is positive, acceleration is negative. That is how we justify speeding up, slowing down. We will do that again later on, but I wanted you to see it again. Okay. Today, we are working on AP graph interpretation questions. There will be one of these questions on the AP exam in May. Okay. It's going to continue to get tougher, but this is one we can handle. It is worth 9 points on the AP exam in May. You only need 40 to pass. You need 40 out of 108. You can score 9 of them on this thing. So we're going to make sure we're good at that. Fill in that chart with your neighbor. Go. There we go. Increasing. If we're increasing, Cannon, what's going to be true about f prime? Careful there. Increasing means the slope is positive, but what am I looking for on f prime? Just positive. Just positive. Don't say the slope is positive. You're looking at something different than what you want there. So you just want f prime to be positive. Luke, when am I decreasing? What's going to be true about f prime? F prime is going to be negative. If I want to have a relative maximum, Renee, what's going to be true about f prime when I have a relative maximum? It's got to change from positive to negative. So Jacob, when am I going to have a relative minimum? You change from negative to positive. Just think about maxes and mins. Oh, that's a minimum? Negative slope to positive slope. That's why I have a minimum. Just think about what a minimum or a maximum looks like. It'll help you out. Concavity. Okay, let's do the furthest one first. Concave up. If I'm talking about concave up, Talon, what is true about f double prime? F double prime is positive. So when am I going to be concave down then, Macy? When f double prime is what? F double prime is negative. And Lulu, what's going to be true with f double prime if I have an inflection point? It just changes signs. Good. It changes signs. F double prime changes signs means I have a point of inflection. Now we got to talk about it in terms of f prime, which I think is the hardest part. Michael, what's going to be true about f prime if I'm concave up? F prime is increasing. Because if f double prime needs to be positive, that means the slope of this thing needs to be positive, which is increasing. So obviously this one is decreasing. And then my last one is, when do I have an inflection point? Alana, what has to be true about f prime for us to have an inflection point? Relative extrema. Okay, you're looking for where f prime has maxes and mins, or when f prime changes slope signs. However you want to say it is fine. They're all the same. Questions? Here we go. We're looking at this question. The first thing you're going to do, anytime they give you a graph question here, anytime I give you a graph, the first thing you should do is circle what it is. It is a graph of f prime. I'm going to write in big bold letters again. Oh yeah, this is f prime. I want my brain to be in the right state of mind. Okay. The function f is differentiable on this closed interval from -1 to 12. And they also told me a point. F of 2 is -3. They don't just tell you that stuff for no reason. There's going to be some reason why they told me that. Okay, we might come back to it. We might not, but I'm going to underline it so I don't forget about it. Graph of f prime is shown. Letter A says, given g of x equals that thing, we want to find g prime at 2. So they gave me g, and I want to find g prime. What do I need to do with that g equation to find g prime? Take the derivative. Do that with your neighbor. Take the derivative. What's the derivative here of g of x? Good. So first is x times the derivative of f, which is f prime. So first times the derivative of the second plus the second times the derivative of the first, which is going to get me 1. Boom. There's my derivative. That would score me a point. That's going to get me something. Okay, we got to get that right. If you don't get that right, you're not getting any points. Make sure you get that right. Then I need to find G prime at 2. So guess, once I have G prime, how I'm going to find G prime at 2? Plug it in. 2 times F prime at 2 plus F at 2 times 1. So 2 times F prime at 2. Show me with your fingers. What is F prime at 2, or F prime of 2 going to be? What are you looking for on that graph? The point. It is F prime. So F prime at 2 just means go to 2 and tell me what the Y value is. Oh, it's 2. Plus F of 2. -3. They told me that right there. They gave it to me. I don't have to get crazy. It's right there. So plus -3. This is my answer. I don't have to do anything else. It's a free response question. Leave it. Okay? We can get an answer. What would my answer actually be? It'd be 1, but there's a decent chance you might do something funky. Okay, so be careful there. But my answer is 1. Nothing hard on it. We good? Letter B. And this is the reason why we're doing these questions. On what interval is F increasing? Justify your answer. Justify your answer is the focus of today. Being able to justify based on a graph. So all these problems we're doing today make a Mad Lib. Okay, we're going to fill in the blanks. On what interval is F increasing? F is increasing on blank interval because. That's what justification means. It's the because part. Because, and then the next thing we are going to write is because what did they give me? They gave me a graph of F prime. So we're going to say because F prime of X blank. You have to write F prime of X. You do not get to say it or the graph or the derivative graph or any of those phrases. You have to say F prime. If you don't, you will get 0 points. Okay? So F is increasing on blank because F prime is blank. I don't need to look at my graph to answer that the second part. If F is increasing, what is true about F prime? Yeah, careful, because F prime is positive. That's the same thing we did in the chart. F is increasing means F prime is positive, because F is increasing means you have positive slope, and F prime is a graph of slope. So I look at that graph. When is F going to be increasing? 0 to 9, because I'm above the x-axis from 0 to 9. Questions on B? Yes, sir. They don't count that wrong, so I don't talk about it. So the question was, at 5, I'm technically 0, and I'm not positive anymore. They have never counted that wrong, so I don't bring it up. But yeah, the better answer would be 0 to 5 and then 5 to 9, but that's weird. All right, the next one. We use brackets because we talk about increasing, decreasing. Anytime we're talking about a first derivative question like increasing or decreasing, we use brackets. Anytime we talk about concavity, we're going to use parentheses. For each of the following, for each of F double prime of 2, so we're F double prime of 2 equals blank. And we're also going to find F double prime at 3 equals blank. We're going to either find the value or explain why it does not exist. Look at that graph, think about what that means, and get an answer with your neighbor. Go. Here we go. Show me with your fingers. What is F double prime at 2? Show me with your fingers. What is F double prime at 2? It is not 0. It is undefined. It does not exist. F double prime at 2 does not exist. What am I looking for on this F prime graph to talk about F double prime? The slope. And I want to know the slope at 2. Can I find the slope at a corner point? No, so that's my answer. F double prime at 2 does not exist because at x equals 2, F prime has a corner point. Nothing fancy about that answer. It's just saying it has a corner point. I'm just saying F prime has a corner point at 2. Okay, however you want to say that is perfectly fine. But something along the lines that I've got a corner point. And that's a great justification. That's all you got to say. F double prime at 3. Show me with your fingers. What is F double prime at 3 going to be? Well, we're not very good at this part. Okay, I see like 1 or 2 right answers. What am I looking for on this F prime graph if I want to know F double prime? The slope of this point right here. It's a straight line. Can I find the slope of a straight line? Yeah, totally. Okay, and this was confusing kids earlier. Don't. I want to know the slope of that line. So all I have to do is find the slope. Okay, use points that you know. So like I've got this point, it is 2, 2. Use that point right there, it's 5, 0. The slope is the same everywhere between those 2 points. So you can just do slope formula and figure it out, or you can just count. I went down 1, 2. I went over 1, 2, 3. So if I do rise over run, what's my slope going to be? Negative 2/3, down 2 over 3. So negative 2 is my rise and 3 is my run. You could have done slope formula and subtracted, but it's the same thing. Just count. Questions on that one? Students struggle finding slope. Just count. Don't make it harder than it is. Flip it over here. Let's do it again. Let f be a function on the closed interval from negative 3 to 4. And then they told me some ordered pairs. The graph of f prime. All right, cool. It's a graph of f prime. I'm going to circle it. I'm going to write f prime of x again so I don't screw it up. On what interval, if any, is f decreasing? Justify. So again, that phrase justify means explain. So if I'm justifying, I'm saying, all right, f is increasing. I'm sorry, decreasing, my bad. F is decreasing on this interval, whatever this interval is, because f prime, because they gave me f prime, my justification, my explanation is going to be in terms of what they gave me. Because f prime blank. F is decreasing means f prime is what? Negative. So f prime is negative. That's all I got to fill in that second blank. Give me the interval. This is a graph of f prime. So from when to when, Madison, am I decrease, or when is f decreasing? From negative 3 to negative 2, because f prime is negative. It's when I'm below the x-axis. It's the only time that graph is below the x-axis. That's 2 easy points on the AP exam. You only need 40. We scored 2 by answering that question correctly. On what x value does f have a relative minimum? Justify. So again, when we see justify, we're going to write this thing out. F has a maximum at x is equal to blank because, oh my bad, I said max, my fault. Minimum has a minimum because that's what it's asking for. It has a minimum at x is equal to blank because f prime blank. Finish that problem. Give me an answer and give me the reasoning. F has a minimum. Show me with your fingers. Where does f have a minimum? F has a minimum at negative 2. Max Harris, why do we have a minimum at negative 2? F prime changes from negative to positive. We can write that down before we do anything else. Find the x coordinate of each point of inflection. Justify our answer. Okay, so F has a point of inflection at blank. Finish this question. Point of inflection at x is equal to. Show me with your fingers. Where do you have a point of inflection? You should have 2 sets of fingers up here. And I see a couple right answers. We have a point of inflection at 0 and 2. Right here and right there. Bottom out, why do I have a point of inflection at those spots? Because what? Yes, good. Because f prime has relative extrema. You can give me that answer. You could say because f prime changes slope signs, or you could say f prime has maxes and mins. I don't know what I'm writing down, sorry. It doesn't matter. It's still a maximum minimum. Because if it's a cusp, that means the derivative is undefined, but that's okay. Remember when we did critical points? We took the derivative, we set it equal to 0 or undefined. It was really either. We just don't get undefined as much, so it seems strange. But it's maxes and mins happen when it's 0 undefined. So does points of inflection. Good question. One more. Find the equation of the line tangent to the graph at x equals 0. Find the equation of the line tangent to the graph. As soon as you read that phrase, find the equation of the line. What am I going to write on my paper? Y minus equals x minus point slope formula. Cool. What's something that I definitely know? Yeah, x equals 0. So x minus 0. Boom, done it. I need to know my y value. Is there any way of getting my y value? What's my y value going to be here? It's up at the top. It's right here. Hello. There's a 3 up there. So I can put that in for my y value. Easy. They gave it to me. Don't let it be harder than that. Then the other thing I need is my slope. Think about it. You are writing the equation of a graph of f. Talk with your neighbor. See what that number is going to be. This one's challenging. Last period, I would say about half my kids got it wrong. Show me with your fingers. What number are you putting in front of that parenthesis right there? The answer is 2. The answer is 2. What does that represent? It represents the what? The slope, right? The slope. This is a graph of f that we're writing the equation of. So I want to know what the slope of f is. Well, guess what f prime tells you? F prime tells you the slope of f. So if I want to know what the slope of f is, all I got to do is go to 0 and look at that y value. The y value is 2. The second derivative is undefined, but the derivative is given to me. It is 2. Does that make sense where I'm getting that number from? A little bit weird, but it's a good one. All right, here's what I'm going to have you do. Okay, you guys did well on your assignment last night. I had an assignment printed off. I'm not going to give it to you. Okay, instead, all I want you to do is do that last problem. Okay, use your brain, think your way through it, work with your neighbor. You got about 5, 6, 7 minutes right now. That's what we're going to start with tomorrow. We'll go over that together and make sure we're on the same page.